Okay, in this lesson we also looked at two special logarithms that exist within our math vocabulary. The first one is called the common log, which is log base 10 of x. And it has a different way that we can write it. It could be written without the 10 actually showing. So like this, and you can see the note here, if there's no base, there is an implied base 10. And so you would need to be able to recognize it either way. Sometimes it will show up as log base 10, but other times when you see this, you need to automatically recognize that this means the base is 10. Our second special logarithm is the natural log, and this one is log base e of x. E, for the record, is not a variable, it's a number. It's a number of about 2.718. In fact, if you wanted to see well, it never actually ends, but if you wanted to see a longer version of e, you could type e into your calculator, and your calculator would generate more of those decimal places if you are curious to see more of it, just like pi, right? We say pi is about 3.14, but we know that it goes further than that. Same thing with e here. Okay, and so you have log base e, that 2.718, which could also sometimes be written as ln of x, which we we call natural log of x. Okay, and so we've got 8 examples here just to kind of see how these two would look, 4 with the log base 10, 4 with the log base e. This particular evaluation method corresponds to the previous video for the examples that came prior to this section, the ones that are up above over here. But so we're going to continue to be evaluating the logarithms, verifying by rewriting in exponential notation. Okay, so number 13. I'm going to do number 13, and then my recommendation is to pause the video, give number 14 a shot on your own, restart it either when you have an answer or are stuck, whichever one happens to come first. That way you can check your answer or get a little bit of help on 14, then do the same thing on 15, pause the video, try it on your own, same with 16. Then maybe watch me do 17, and then pause the video, 18, 19, 20, so that you're getting that practice on your own rather than just watching me walk through all the problems. Okay, so here we go. 13, we notice that we have a log without a written base. That tells me that that base is 10. And so the question is, well, what is that exponent so that I would get 100, which is the value inside the logarithm? Well, in this case, that exponent would need to be 2, because then 10 squared would be 100, and so log base 10 of 100 is 2. Okay, number 14. Pause the video if you're going to. Number 14, we have a log without a written base. That means this is base 10. So the question is, well, what is its exponent? So that I would get root 10 as an answer, because root 10 is what's inside of the logarithm. Well, in this case, that exponent would need to be 1/2, because 10 to the 1/2 would be root 10. Okay. Number 15, we have no written base, so again, base 10. What would the exponent need to be to get 10 cubed? This one's kind of funny, because the base is already matched, so this exponent would need to be 3, because if my exponent was 3, I would then have 10 cubed. And then last one for this log base 10 is number 16. So again, no written base, so we have a base of 10. What would the exponent need to be to give me 1/10 squared? Okay, well in this case, I need this 10 to drop down into the denominator, so that tells me that I would need my exponent to be a negative. And then I want to get 2, so that I have 10 squared, and so my answer would be -2. Okay, number 17. 17 is our first with the natural log. So I've got here, the natural log of e cubed. So when you see natural log, that tells you your base is e. So the question is, what does that exponent need to be to give me e cubed? Well, this one's a lot like number 15 earlier. My e's are matching already, so my exponent would need to be 3, because then e cubed would be, well, e cubed. For the record, you're going to learn in a later lesson that this natural log and this e are, because they are inverses of each other, they cancel each other out, resulting in 1, and so then you'd be left with 1 times 3, which is 3. And so we kind of see that future concept modeled in this problem a little bit. Okay? Okay, 18, pause the video if you're going to. 18, again, we have a natural log, so that's a base e. The question is, what does the exponent need to be to give me 1? And in this case, that exponent would need to be 0, because then e to the 0 would be 1. Number 19, another natural log, so base e. What does that exponent need to be to give me 1 over e to the 5th? Okay, well this one's a lot like 16. For that e to drop down into the denominator, my exponent would need to be negative. And then I want it to be e to the 5th, so I'm going to have negative 5 as my exponent. Okay, and then last but not least, another natural log, base of e. What does that exponent need to be to give me the cube root of e? Well, a root tells me that this is some sort of fraction. And in this case, I should say a fraction is an exponent. In this case, it's a cube root. So that means it's going to be 1/3. Because then e to the 1/3 would be the cube root of e. Okay, and those are your two special logs.